Wood is a natural composite made out of cellulose fibers and liquid matrix. The most advanced example of composites are used in spacecrafts in very, very demanding environments. An everyday example of composites are the pavement of our roadways, which made from either steel or aggregate reinforced Portland cement or asphalt concrete. Another example is nanocomposites. So nanocomposites actually are a specific type of composites. The usage of nanocomposites to substitute metal in rotor blades of the helicopter Siegel 61 increased its range 15% and its speed 28 km per hour at reduced power. Hello, I'm Erdogan and I'm going to introduce you some nanotechnology concepts. If you're curious to know what graphene epoxy nanocomposite is, please stay with me for a couple of minutes. Composite materials made from two or more constituent materials or phases which have different properties. For example, cement, which is used for making concrete, shows very good properties in compression while not that good properties in tension. Constituent materials or phases divided to two groups, matrix and reinforcement. So what will happen is, in composite material, at least one portion of each is required. The matrix supports and surrounds the reinforcement. How? By maintaining it their relative positions. But why that is so important? The reason is the reinforcements impart their special properties to enhance the properties of the matrix, and as a result, the combination will be stronger than individual materials. Something similar to the concept of unity in human beings. So, not only these working together make the product or the composite stronger, but also wide variety of matrix and strengthening materials allows the designer of the product to choose an optimal combination for the material. Well, nanocomposites are a special type of composites in which one of the phases or constituents has 1, 2, or 3 dimensions of less than 100 nanometers. Our structure having nanoscale repeat distances between the different phases that make up the material. In terms of mechanical properties, nanocomposites are different from the conventional composites, and the reason is the high surface to volume ratio of the constituents or reinforcing phase. Pay attention to the amount of red color, which is indicating the perimeter of the particles in the composites and nanocomposites. You can easily notice its increase in the nanocomposite. It is called interface. The area of the interface between the matrix and reinforcement phases are typically an order of magnitude greater than for conventional composite materials. The matrix material properties can be significantly affected in the vicinity of the reinforcement. Researchers found that the local chemical properties can continuously and significantly change from the interface with the reinforcement into the bulk matrix. So what does it mean? It means that large surface area of the nanoscale reinforcement can make significant change in macro scale properties of the composite.
Carbon is fourth most abundant element in the universe. Carbon-carbon bonds is unique and one of the strongest existing bonds in nature. In the last 2 decades, new structures of carbon material based on carbon-carbon bond created a revolution in science and technology. These new materials can be structured in different ways. For example, a spherical structure of carbon atoms called fullerenes, carbon nanotubes, which are large chains of carbon atoms shaped like tubes. Carbon nanotubes are 1 to 3 nanometers in diameter and thousands of nanometers long, which this length to diameter ratio is significantly larger than any other known material. Nanotubes are categorized as single ball construct of single tube of carbon atoms, and multi-ball consists of multiple tubes of carbon atoms. Graphene is also another new structure of carbon, first fabricated by a group in the University of Manchester. Graphene is a single atom thick sheet of carbon atoms and are densely packed in a honeycomb lattice form. Graphene looks like an atomic scale chicken wire made of carbon atoms and is a type of material has great electrical, optical, thermal and mechanical properties and has shown tremendous improvements in many applications. Graphene is the strongest and thinnest ever measured material also.
For making the graphene epoxy nanocomposite, first, epoxy resin should be added to the mixture of graphene and acetone. This mixture helps graphene nanoparticles disperse better. Then, the samples should be stirred and put under the vacuum with heating at the same time to remove the acetone. The next step is adding the hardener. For well mixing the hardener with the materials, high-speed shear mixing should be used for at least 3 minutes. To remove air bubbles from the sample, it is degassed under vacuum for 10 to 20 minutes, after which the sample can be poured into the molds, and after 24 hours, the samples will be cured and the nanocomposite will be ready.
Graphene Epoxy Nanocomposite is an ongoing research topic, and experts currently work to improve their properties. These type of nanocomposites have great potential for various industrial purposes, and there may be more news about them and about their new applications.